Good afternoon, everyone, and welcome to this lecture. This is Thermodynamics lecture number 10, and we are dealing with work done in various processes. In the previous class, we had seen the work done in various processes. Yes or no? Starting from Isochoric, work done is 0. Isobaric, P into V2 minus V1. Isothermal, I had given you the formula, and also for an adiabatic process. Have you gone through this formula, everyone? We had seen the work done in a cyclic process is the area in between the graph. If it is a clockwise cycle, it's positive. It is anti-clockwise, it is negative. Yes or no? And we had also seen work done is a path dependent process, and we had seen free expansion as well. Now there is one more case where you could find out the work done if you have a piston loaded with a spring. This particular case, if someone tells you to find out the work done, how will you find out the work done in this case? This would be a spring whose spring constant will be given as K. Okay. Then there is a mass. It could be the mass of the piston, or it could be mass of an object which is kept on the piston. And this will be open to atmosphere, so there will be an atmospheric pressure P naught as well. Now, if the gas is expanding against all this, what will be the work done in this process? Now, the work done in this process, if I say that the area of cross section of this cylinder is A, now we have to do work. This pressure P of the gas, the system has to be in equilibrium. So this pressure P of the gas will be equating this atmospheric pressure, this force due to the spring, this force due to mg as well. Yes or no? So are you understanding what I'm saying here? Yes or
Yes,
no?
sir.
Now this pressure which will be here, P naught, if I write the value of this P naught, this will P naught will be equal to P plus mg by A, which is the pressure exerted by the weight. Do we understand this? And then there will be spring force. Now the spring, we assume that it is compressed by a distance x. So it will be also exerting force in the downward direction. So the spring force will be kx divided by A. Yes or no?
Yes, sir.
The work done in this process will be, sorry, I have not written, why did I write is P? This will be P, and this atmospheric pressure will be P naught. So this will be the pressure against which the work would be done. The work done in this case by the pressure of the gas will be P naught into V. This is the work done against the outside pressure, plus mg into x. This is the work done against the force mg, plus work done against the spring force will be half kx square. So in this case, the work done would be given by this formula. Do we understand this?
Yes, sir.
So remember this. In most of the cases, this question may not come, but if it comes, you should be ready with the answer for this question. Have you noted it down?
1 minute.
Let me know once you are done. Then you have this question. A thermodynamic system is taken through a process PQ. So from P to Q to R to S to P. What is the net work, total work done by the system in this complete process? You understand the question? Yes or no?
Yes.
I'll give you 2 minutes to give me the answer. So how do we get the answer for this one? You just have to find the area of this length into breadth with the correct units. The cycle is anti-clockwise, so the work done would be negative, and I think you are going to get the answer is minus 20 joules. Everyone got the answer? Yes or no? This is the next question then. Give you 2 minutes to solve this. So you just have to find out the area of this triangle, I think. And the area of this triangle is very simple, half base into height. Base is 2v and the height is 2p. So half into 2 into 2 PV, and it is not given. The cycle is AB. So I will just write the cycle AB, BC, CD. So it's a clockwise cycle. So it will be plus 2PV. Do we understand this? Yes or no? No, yes?
Yes, sir.
Everyone understands this? You understand this? Yes or no?
Yes, sir.
Okay. Let me now give you this question. So the next question comes up like this. A non-conducting piston of mass m and area of cross-section A is placed in a non-conducting cylinder. Temperature, spring constant and height of the piston are given by T, K and H. Initially the spring is relaxed and the piston is at rest. Find the number of moles. Work done by the gas to displace the piston by a distance d in the upward direction. I'll give you 2 minutes to give me the answer for this one.
mgh
Okay, tell me.
work done equals to V plus mgh by RT, sir.
The first question is find the number of moles. What is the number of moles?
That is V plus mgh by RT, sir.
Number of moles. So you have to first find out the inside pressure. Inside pressure P will be equal to P atmosphere plus mg by A. Yes or no?
Yes, sir.
And then you have to apply the ideal gas equation. PV is
PV
equal to nRT. The volume is A into H. So the number of moles becomes P atmosphere plus mg by A multiplied by A into H divided by R into T. We got this answer, yes or no?
Sir, P atmosphere will be 1. No, sir.
P atmosphere. It is given as P atmosphere. It is given as P atmosphere.
Okay,
Okay.
sir.
Then the work done in this case, I think I have already given you that concept, that formula, yes or no? So it will be
Yes, sir.
mg into d plus P atmosphere into A into d plus half k d square. Yes or no?
Yes, sir.
That is the answer. Well done. Everyone has understood this. Yes or no? No or yes?
Sir,
Yes?
volume will be A into D plus H, no, sir.
Take a deep breath. P into dV. Change in volume, beta. In the question that I gave you, did I give you original volume plus X? See? No, na? Do you understand this?
Yes, sir.
Okay, let me give you the next question. And the next question is this. I'll give you 2 minutes to solve this one. Read the question and give me the answer. Remember, whenever the question says that the process is happening in conducting walls, the surrounding temperature is T and it is open to atmosphere, walls are conducting. This is a case of an isothermal process. This is the case of an
Isothermal process.
now if I call the pressure inside as P, it is open to atmosphere, so there will be atmospheric pressure. Do we understand this? Yes or no?
Yes, sir.
There would be atmospheric pressure. The piston is displaced by an external force. So for the equilibrium, if I apply the external force in this direction, this F plus P into A will be P naught into A. Yes or no?
Yes, sir.
We have to find the work done by the external force. So that will be PA minus P naught A dx का integral. Yes or no?
Sir, PA.
Sorry. P naught A. Yes or no?
Yes, sir.
This P naught A. So this will be integral of P naught into A dx minus integral of P into dV. Yes or no?
Yes,
This
sir.
one is isothermal process. And this one is a process at constant pressure. Atmospheric pressure is constant. Yes or no? Do we understand this? So the work
Yes.
done will be P naught into change in volume. Change in volume is V. Yes or no?
Yes, sir.
Minus this will be nRT into natural log of final volume is 2V. Initial volume is V. So it becomes minus nRT ln of 2. Do we understand this?
Yes, sir.
This is how this question is done.
Sir, what is P naught here?
Atmospheric pressure, beta.
But there is no like that.
Everything may not be given. In this question, atmospheric pressure is not given. But whenever the piston is open to atmosphere, you have to take into account the atmospheric pressure. Do we understand this?
Yes,
Yes
sir.
or no? We understand this? We understand this? I'll give you
Yes,
2 minutes to note it down. So we understand this question.
yes, sir.
First part is find out the work done. That is very simple. You can straight away give me the answer. Then the next part is draw the TV and the PT graph. I'll give you 2 minutes to give me the answer. The first part is simple. The work done is P naught into V naught. Yes or no? Yes or no?
Yes, sir.
Now look at how you draw the TV graph or the PT graph. Remember, you will not be asked to draw the graph. They will give you 4 options. You have to choose the correct one. What is this process?
Isobaric.
Isobaric. Constant pressure. What is this process?
Isochoric.
Constant volume. Again, the same process is getting repeated. Do we understand this?
Yes, sir.
So the TV graph, remember, one is isobaric from A to B is isochoric. Isobaric process, it will be a straight line like this. Yes or no? Pressure is increasing, volume is increasing, and therefore the graph goes like this. Do we understand this? This is the TV graph. You understand this? Yes or no? No, yes.
Yes, sir.
I'll show the PT graph as well. This is the PT graph. AB is the isochoric process, and therefore it is a straight line. Pressure is increasing, temperature is increasing. Do we understand this?
Yes.
Everyone got this? Yes or no? No or yes?
Yes, sir.
I'll give you 2 minutes to draw this and understand it. Let me know once you're done. And let us move on to the next question. In this question, the TV graph is given. TV curve. The number of moles are n. Find the total work done during the cycle. What is the total work done during the cycle? I've already told you whatever you needed to know. You just have to identify the process, get the answer, and stay happy. I'll give you 2 minutes to give me the answer. You have to understand the question. You have not understood the question. The area under PV graph gives you work done, not TV graph. There is no point of finding out the area of this graph. You have to use some common sense. And what is the common sense? What is this process from A to B?
Isochoric, sir.
So the work done in this process is
0.
what is this process?
It's also isochoric, sir.
Work done in this process?
0.
What is this process?
Isothermal.
What is the work done in this process?
NRT LAN V
NR. What is the temperature?
2 T naught, sir.
Natural log of
V final minus V initial.
V final divided by V initial. Take a deep breath. So 2 V naught divided by V naught, it will be 2. ln of 2. Yes or no?
Yes, sir.
What is this process?
It's also isothermal, sir.
What is the work done in this process?
It's minus NRT naught ln 1/2, sir.
Take a deep breath. If you have put minus sign, why did you put minus sign first of all? Don't have to put the minus sign if you are saying
Volume is
ln.
decreased, no, sir.
Take a deep breath and then try to do it. Take a deep breath. Deep breath. Close your eyes. Work done is negative because final volume is less than the initial volume. So if I put it in the formula, final initial, automatically work done will get the correct sign. You are putting a negative sign and then you are putting the formula, you will get the wrong answer. You can understand this?
Yes, sir.
So either you call it as nRT naught ln of 1 by 2, or you say it as minus ln RT ln of 2. You cannot say both. You first put a negative sign and then you put the original volumes. Just cannot do that. Yes or no? So this will become minus nRT naught ln of 2. So the total work done in this cycle will be how much?
0, sir.
nRT naught ln of 2. That will be the answer. Yes or no? You have to be very patient. Open your eyes. This is nR2 T naught. This is nR T naught. Open your eyes, then see, and then give the answer. Do we understand this? Be very careful, because if you just do a simple mistake, instead of getting +4, you will get -5. From where I see, you lose 9 marks. Do we understand this?
Yes.
Yes or no? Identify the process, look at the diagram, see the formula. I've given you everything that you require. You just have to be patient and do not do it in a haste. Okay, shall I move on to the next one? Yes or no? No, yes.
Yes, sir.
Pakka na, sir?
Yes, sir.
This is the next one. So I'm given you all types of processes, TV, PT, PV, so that you are confident in finding out the work done in all the processes, and the formula of work done gets embedded in your heads. PT was the only one that is left. And this is the PT graph. PT graph of a cyclic process is shown in the figure. Find out the work done by the gas in the given process, the entire cyclic process. The number of moles is given are n. Take a deep breath, try to understand, mark what process you can see, what you can understand. Every question is a question that may come in your JEE. So what is the answer?
NR into T1 plus T3 minus T2 plus T4.
So T1 and T3 are plus and T2 and T4 are minus. Is that what you are saying?
Yes, sir.
That is exactly correct. Once you identify the process, the things become very simple. Which process is this?
Isochoric, sir.
So work done in this process is 0. What is this process?
Isochoric work done equals to 0.
What is this process?
Isobaric.
Work done is 0 in this process. In this process, it is isobaric. So P into V2 minus V1. So that becomes NR into
T.
3 minus T2. Yes or no?
Yes, sir.
And in this case, it becomes nR into T1 minus T4, final temperature minus initial temperature. Yes or no?
Yes, sir.
You just add all of these and you get your answer. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay, we have done, we have seen delta Q, part dependent, depends on the process. We have seen delta W, part dependent, dependent on the process. Now we come to the third thing. What is the third thing? Internal energy or the change in internal energy. Yes or no?
Yes, sir.
Again, just a quick recap for an ideal gas. Internal energy, potential energy is zero. Yes or no?
Yes, sir.
Now, this internal energy or change in internal energy is a state variable. Yes or no?
Yes, sir.
Therefore, change in internal energy does not depend on what? It does not depend on what? It does not depend on path or process. Yes or no?
Yes, sir.
It is always same or constant. What is the change in internal energy? We can write it in different ways. F by 2 nr delta T. Yes or no?
Yes, sir.
Or I can write it as NCV delta T. Yes or no?
Yes, sir.
Now, CV is F by 2R. I can also write it as R upon gamma minus 1. Yes or no?
Yes, sir.
So I can write it as NR into delta T upon gamma minus 1. Yes or no?
Yes, sir.
I can also write it as NR into T2 minus T1 upon gamma minus 1. Yes or no?
Yes, sir.
NR into T2 can be written as P2V2 minus P1V1 upon gamma minus 1. So these are the different ways in which you can write the internal energy or the change in internal energy. Do we understand this? Yes or no? No or yes?
Yes, sir.
Change in internal energy does not depend on the path. It's a point function. It's a state variable. Yes or no? No or yes?
Yes, sir.
For a cyclic process, for the complete cyclic process, you start from the first point and you end up on the same point. Yes or no? So
Yes,
what
sir.
will be the change in internal energy for a cyclic process? For a complete cyclic process, the change in internal energy has to be zero. Yes or no?
Yes, sir.
Everyone understands this, or this has gone above our head saying bye bye? We understand this, everyone?
Yes, sir.
Okay, I'll give you 2 minutes to note it down. That takes us to the next heading, the most important heading of this chapter, which is known as, we have seen the zeroth law of thermodynamics. This is the first law of thermodynamics. First law of thermodynamics. What does this first law of thermodynamics say? Remember, this first law of thermodynamics is based on the law of conservation of what?
Energy.
is based on LOCE, Law of Conservation of Energy. Energy cannot be created, energy cannot be destroyed, it can only be transferred from one form to another. If you give delta Q amount of heat to a gas or a system, some amount of energy will be given to change the internal energy and the rest will be given out as work. This revolutionary statement is known as the statement of the first law of thermodynamics. Do we understand this? This has gone above our heads. Saying bye bye.
Understood, sir.
Akka sir, we must know this. Yes or no?
Yes,
No,
sir.
you may not have to write the entire statement. This is just for your academic purpose. I am giving you the statement. You just need to worry about the first statement. Delta Q is d delta W plus delta W. You can also write it in the differential form. The differential form, if you give small amount of heat dq, that will be equal to small amount of change in energy plus small amount of work done. Do we understand this? Yes or no? No, yes.
Understood, sir.
Everyone understands this? Now, what important points you have to remember about this? This law is applicable for every process in nature. Whatever process you are talking about, this law is applicable to every process in nature. This law gives us the definition of internal energy. How does the internal energy come? If you give heat, it gets converted into internal energy. Are we able to understand this, or this is going above our head saying bye bye?
Understood, sir.
All the units of delta Q, delta U, and delta W should be same. You can use them in calories or you can use them in joules. Doesn't matter. This law is applicable to all states of matter, whether they are solid, liquid, or gas. Delta U, the change in internal energy, is a state variable. It consists of all types of energy that the system may have. Do we understand this? All these are small points about the first law of thermodynamics. I'll give you 2 minutes to note it down. Whenever we are using this first law of thermodynamics, we must follow a sign convention. You already know the sign convention. Probably I did not tell you the sign convention of delta U. Delta U is change in internal energy, and CV delta T. If temperature increases, internal energy increases, it will be taken as positive. If temperature decreases, internal energy will decrease and it will be taken as negative. Rest all of us, all of I have told you yes or no, no, yes.
Yes, sir.
You have 1 minute to note it down. Then let us start with the simplest possible question, just to give you how you are supposed to apply. This is the simplest possible question which has the simplest possible answer, which I am waiting that you can give me as soon as possible. 150 joules of heat is added to a system and the work done by the system is 110 joules. What is the change in the internal energy? And you will have 2 minutes to give me the answer for this one. I think you can give it very quickly. Yes or no?
Yes, sir. 40 joules. Sir.
Yes, we got the answer.
40 joules, sir.
40 joules is correct. 40 joules is correct. And it is a straightforward question. I don't think I need to explain anything. Delta Q is delta U plus delta W. Delta Q is given as 150. Delta W, work done by the gas, so it is expansion, so it is positive. And the rest of the answer is pretty damn simple. Yes or no, no or yes.
Yes, sir.
Uh, this question we have already done. This one comes on your screen now. I'm hoping to get an answer quickly for this one. A gas is compressed at constant pressure of 50 Newton per meter square from a volume of 10 meter cube to a volume of 4 meter cube. Energy of 100 joules is then added to the gas by heating. What happens to the internal energy? You have 2 minutes to give me the answer. What is the answer? A, B, C, D. Increase by 400, increase by 200. One. Option 1. Okay. How are we supposed to do this? Delta Q is equal to delta U plus delta W. 100 joules is given, so 100, that will be equal to delta U plus work done. Constant pressure P into V2. V2 is 4 minus V1. So from there you will get change in internal energy is 400 joules with a positive sign. That means the correct option is option A. We got this, yes or no, everyone? Okay. Comes this next question, and these are the type of question that are coming in the JEE these days. So I'll give you this one. A thermodynamic process is shown in the figure. The pressure and volume of some points is given. Point A, point B, volume at point A and volume at point D. In the process A to B, 600 joules is added to the system, and in the process B to C, 200 joules is added. What is the change in internal energy in the process A to C? Think about it. I'll give you 5 minutes and give me the answer. So, how do we do this? Now, go by process to process. What is this process? A to B.
Isochoric, sir.
So the work done in this process is 0.
So,
Yes or no?
isobaric work done will be P into V2 minus V1.
P into V2 minus V1. So this will be 8 into 10 raised to the power 4
Or-
multiplied by V2 minus V1 is, forget about the units, forget about the power. This will be 5 minus 2, that is 3. Yes or no?
Yes, sir.
240 it will come probably.
Minus 3, sir.
Minus 3?
Into the power of minus 3, sir. Into.
Whatever. I'm not worried about the unit. I'm just worried about that numbers. Okay. So in the process A to B, 600 joules is added, and in the process B to C, 800 joules is added. So total amount of heat that is added is 800 joules. Yes or no?
Yes, sir.
And the total work done is, I think, 240 joules. Yes or no?
Yes, sir.
That will give the change in internal energy from A to B and A to C. That means from A to C. Yes or no?
Yes, sir.
And it does not depend on path. So whatever path you go, it will be same. So it will be same in all the path, and that will be equal to 560 joules. This is how questions are framed, and this is how questions are done. Do we understand this?
Understood, sir.
Everyone understands this?
Yes, sir.
Most of the question that you're going to face in the exam will be based on these types. So one more coming up on your way. Take deep breaths. Just follow the process. You know everything that you need to know. You just have to solve it. A sample of an ideal gas is taken through a cyclic process A to B to C to A. It absorbs. Absorbs means it takes in 50 joules of heat during the process A to B, no heat during the process B to C, and rejects 70 joules of heat during C to A. 40 joules of work is done in the process B to C. If the internal energy at B and C, find the internal energy at B and C if it is 1500 joules at A. Calculate the work done by the process by the gas in the process C to A. This will clear all the doubts that you have in your mind. I'll give you 2 minutes to give me the answer. So how are we supposed to do this? We do simple things. I look at the process, starting process. The starting process is A to B. A to B. What type of process is A to B?
Isochoric.
Isochoric. So work done in this process is how much?
0.
0. For the process A to B, let me write the first law of thermodynamics. What is the first law of thermodynamics? It absorbs 50 joules. That should be equal to delta U plus work done. Work done is 0. So change in internal energy is plus 50 joules. Yes or no?
Yes.
At point A, the internal energy is 1500. So what will be the internal energy at point B? At point A, the internal energy is 1500 joules.
8 joules.
So at point B, the energy will be 1550 joules. Yes or no? Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
That takes me to the next process. Next process is from B to C. B to C, let me call this as no heat is given during the process B to C and 40 joules of work is done during B to C. 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 40, no heat is given. So delta Q is 0. 40 joules of work is done. Delta U minus 40 joules of work is done. So change in internal energy will be 40 joules. Yes or no?
Yes, sir.
So what will be the internal energy at point C? (1590 joules. Yes or no? Yes or no? No or yes? Do we understand this?
Yes, sir.
Then comes the last part. C to A. C to A. C to A. Green one. 70 joules of heat is rejected. So minus 70 is equal to change in internal energy. The final energy is 1500. The initial energy is 1590. What is the change in internal energy, my dear friend? Minus 90. Yes or no? No or yes? Plus the work done. You will get the work done as plus 20 joules. And these are the set of answers that we were looking at. Do we understand this? Yes or no? No or yes?
Yes.
Pakka?
Yes, sir.
Pakka? Shall I give you the next question? Shall I present the next question? Huh?
Yes.
This is the next question. 2 moles of a diatomic gas at 300 Kelvin is kept in a non-conducting container enclosed by a piston. The gas is now compressed to increase the temperature from 300 Kelvin to 400 Kelvin. Find the work done by the gas. Whenever someone says non-conducting container, if they say conducting, that means the process is isothermal. If they say non-conducting, then the process is, it cannot conduct heat outside. Outside heat cannot come inside.
Delta Q equals to 0.
So this becomes an adiabatic process. Delta Q becomes equal to 0. Do we understand this? Yes or no?
Yes, sir.
You have 2 minutes to give me the answer for this one. It's a very simple question, bacha. For any process, delta Q is equal to delta U plus delta W. Yes or no? Yes or no?
Yes, sir.
I'd given you the work done for an adiabatic process as well. You know the change in internal energy as well. Here, the delta Q is 0. So delta W will be negative of delta U, negative of N CV into delta T. That is all you need to do, my dear friends. CV for this number of moles is 2. CV is 5 by 2R into delta T 400 minus 300. That is the answer, my dear friends, that we are looking at. The answer is 500 R.
Sir, what we should take the value of R, sir?
8.3. You can just give the answer in terms of R. They will give you the value of R. I'm not worried about the calculation. I'm more worried about whether you have understood the concept or not. Have you understood this? Yes or no? No or yes?
Yes, sir.
Everyone has understood this?
Yes, sir.
So this last one, and then we'll move ahead on to different types of questions. A sample of gas F is 5 is heated at constant pressure. If an amount of 140 joules of heat is supplied to the gas, find the change in internal energy and the work done by the gas. I'll give you 2 minutes to give me the answer for this one. Everything is given to you. I don't know what you are.
Sir, internal energy is 100 and work done is 40, sir.
You've taken a lot of time to calculate this beta. Delta Q is equal to delta U plus delta W. Yes or no? Delta Q is NCP delta T. Yes or no?
Yes, sir.
Constant pressure. Delta U is NCV delta T. Yes or no?
Yes, sir.
So we have done it. Delta Q by delta U will be CV divided by CP. Yes or no?
Yes, sir.
5 by 7. You know the value of delta Q. So delta U will come straight away as 100 joules and delta W will come as 40 joules. Do we understand this? Remember these small things, bacha. Small things are going to make a lot of difference. That is why I'm going to so much strength to give you so many different types of questions so that you are able to understand. Shall I move ahead?
Yes, sir.
Do it fast. Remember, JEE is all about your speed. Fast. Fast. 2 moles of a diatomic gas at 300 Kelvin is enclosed in a cylinder as shown in the figure. Piston is light. Find out the heat given. If the gas is slowly heated to 400 Kelvin in the following cases. Number 1, piston is free to move. Number 2, piston does not move. Number 3, piston is heavy and movable. Just have to understand the process, get the answer, and stay happy. Stay happy. 2 minutes you have to stay happy. In the first process, it is free to move. It is open to atmosphere. Do you see this atmosphere? Huh?
Yes, sir. It's
So this
constant pressure.
constant pressure, yes or no?
Yes, sir.
So the answer is NCP delta T.
Yes, sir.
Well done. Second process.
It's isochoric process. So, sorry, isochoric process. So NCV delta T.
Third.
That's we didn't get, sir.
Array, the piston is light or heavy, doesn't matter. It is still a constant pressure process. Open to atmosphere. So if the piston is heavy, it will again have extra pressure onto it. Do we understand this? Yes or no? No, yes.
Yes, sir.
Work done would be different. That's a different issue. Because pressure has changed. Constant pressure has changed. Pressure has become, oh. The distance that it moves will change, but it still remains a constant pressure process. NCP delta T. Do we understand this? So this has gone above our saying bye bye, bye bye, bye bye.
Understood, sir.
Pakka na sir?
Yes, sir.
Chalo then. This one. I think I've covered almost every hook and nook. PV graph of a diatomic gas is shown in the figure. Find the total heat given to the gas in the process A to B and B to C.
It's isochoric n equals to 0. Delta Q
So
equals to NCV delta T.
from A to B, this is a constant volume process. Yes or no?
Yes, sir.
So delta W is equal to 0. Delta Q is equal to delta U. That will be equal to NCV delta T. So NCV is 5 by 2R
Yes, sir.
into delta T. How will you find out delta T?
T2 minus T1. That will be
2V2 minus P1 V1 will give you NR delta T. So it
yes.
will be 2, I mean,
V naught into 2 P naught minus P naught.
V naught into 2 P naught minus V naught. So it will become
5 by 2 P naught. 5 by 2 P naught V naught.
5 by 2 P naught V naught.
Yes, sir.
In the next process,
Isothermal process.
B to C, this is an isothermal process. In an isothermal process,
Delta Q is equals to P1 V1 into ln V2 by V1.
The change in internal energy will be 0, yes or no?
Yes, sir.
That's it. So you have your delta Q, that will be equal to delta W, and we have already calculated delta W, NR into T naught into ln of 2, and this NR into T naught is 2 P naught into V naught, yes or no?
Yes, sir.
You just add this with this and you get your answer. Do we understand this?
It is 31/10 P naught V naught, sir.
Arey, how there is ln2 also there, na? So you just keep it in the form of ln2. Okay? There's ln2 also coming there, no? Yes or no?
It is 2.03 into 3.
Take it. Okay, if you gave me answer in that way, I did not take it that way. I would always take it in the form of ln. I still don't remember what is the value of ln2. How much ln2?
Sir, it is 2.303 into 0.3.
Okay, so whatever that comes, I'm not concerned with that. Okay,
Yes, sir.
shall we move ahead now? Now what we'll do is we will try to bisect, we will try to see all the processes in detail. We have almost done everything. We will just now look at all the processes in detail and understand them. So if any question comes on that, we will try and do it. So application of first law of thermodynamics, application of FLTD. FLTD means first law of thermodynamics. Application of FLTD. Now, the first two processes that we are going to discuss, they have come recently in JEE Advanced of the last year. The first process is the melting process of ice. Melting. Melting of ice. Now, when ice melts, you must understand that the change in volume of that ice or water is very less. Do we understand this?
Yes, sir.
The change in volume is very less. Since the change in volume is very less, you can assume that the work done is 0. Yes or no?
Yes, sir.
And when the body is melting, it is going to take the amount of heat which is equal to m into L, mass into the latent heat. Yes or no?
Yes, sir.
Now you can apply the first law of thermodynamics. Work done is 0. So from there you will get this equation. The heat given ml will be equal to the change in internal energy. When the ice is melting, it will absorb heat, so its internal energy will increase. When the water is freezing, it will release heat, its internal energy will decrease. By how much amount? M into L. Do we understand this? Yes or no? No, yes.
Yes, sir.
Melting of ice did not come in last year JEE Advance. Boiling of water came. Same question which I did came in the exam. First, note down melting of ice. Then what would be the next process? The first process is melting of ice. Yes, my dear friends. The next process will be boiling, and more often or not, this will be boiling of water. Since this has come in the last year JEE Advance, it may not come in JEE Advance, but it can very well come in one of your JEE main paper. Now, what's a significant difference between melting and boiling? In melting, when ice converts into water, the volume is not significantly changed. Yes or no?
Yes, sir.
But in boiling, there is a large change in volume. Therefore, we cannot neglect that work done. Yes or no?
Yes, sir.
So there will be work done in expanding, and that will be at constant pressure. 100°C means that is the boiling point of water at 1 atmosphere. So normally the change in volume, the work done during this change in volume will be considered at constant pressure. Do we understand this?
Yes.
And therefore the work done will be P, which will be the atmospheric pressure into V2 minus V1. Yes or no? No or yes?
Yes, sir.
Now it will be absorbing heat as well. That will be equal to M into L. Yes or no?
Yes, sir.
And there will be the change in internal energy. So from there you can find out the change in internal energy from the first law of thermodynamics. Do we understand this equation that has appeared on your board all of a sudden? We understand this.
Yes, sir.
Give you 2 minutes to note it down. Let me, instead of giving you a question that I would normally give, let me give you question of this JEE Advanced only, so that you can understand what type of question actually come in a JEE Advanced paper. And you can see that this is JEE Advanced of last year, so it's the latest one. I hope you can see this question. This was a match the following question. It had two lists, and then it had various options. Which of the option is correct? So as you can see, you don't have to solve the entire question. Remember, JEE, whether it is main or advanced, it is a test of your speed. Now looking at this match the following question, you will imagine that this was a question of, I think, 4 marks or 5 marks. You would imagine that you will have to solve all the 4 parts. But if you look at the options, if you just solve the first part, do you see? In first part, all the options are different. Yes or no?
Yes, sir.
If you just solve the first part, the question is solved. You don't have to solve all the parts. Do you understand this?
Yes, sir.
Yes or no? Just have to
Yes, sir.
solve the first part, and the first part is what we have done just right now. That will give you +4 in JEE Advanced. 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 I leave it to you. The question is there in front of you. You have 2 minutes to show me your talents. And you can do all the other parts as well, because everything else you have to find out in all these parts. You have to find out the change in internal energy, and I have given you 1500 questions on that. That is what you have to find out in all these questions. So you can note down these questions and do them at home. Right now I'm only concerned with the first one, because rest of them I've given you 1500 questions on them. 2 minutes you have to show me your talents. Option C, sir, is absolutely correct, sir. Don't have to do the other questions. You can just do this one. And you have to find delta U. Delta U is equal to delta Q minus delta W. Yes or no? No or yes?
Yes, sir.
Delta Q is M into L minus delta W is P into delta V. P is given atmospheric pressure 10 raised to the power 5, 10 raised to the power 5 into change in volume 10 raised to the power minus 3 minus 10 raised to the power minus 6, and you do all this, I think you will end up somewhere with 2 kilojoules. So to solve that question, you don't have to do anything, but you can solve the other questions as well. What will be the answer for this question? See, 0.2 moles of a rigid diatomic gas, 5/2 R. Isobaric expansion. Volume 3V. Change in internal energy. NCV delta T. That is the answer. Do you understand this? Yes or no? No, yes.
Yes, sir.
One mole of a third one. 1 mole of a monatomic gas compressed adiabatically from here to here. Find the change in internal energy. P1 V1 minus P2 V2 upon gamma minus 1. Yes or no? No, yes. P2 V2 minus P1 V1 upon gamma minus 1. Yes or no? No, yes. Huh? Do we understand this, or this is going above our head saying bye bye? Bye bye.
Understood.
Bye bye. 3 moles of an ideal dot diatomic gas in microgram vibrate, vibrate, vibrate. Degrees of freedom become 7. Vibrate, vibrate. Do you understand? Vibrate, vibrate, vibrate. Is given 9 kilojoules of these undergo isochoric expansion. Delta U by delta Q is CV by CV 7 by 9. Do we understand this?
Yes, sir.
See, life is so simple. JEE is so simple if you do the right things in the right way. This is JEE advanced. Chalo, on that great note, I will finish lecture here. And what? The next class we will bisect, dissect, and all those things of all the different processes and try to wind up thermodynamics all apart in the next class. Then heat transfer would be left that we will deal in the 2 or 3 classes. So by the end of this week, in all probability, by Sunday we will be done with your thermodynamics. On Monday we will start with electrostatics. That's it. That's how the plan goes. And by Monday probably you will. Are you going to give your exams this time, first attempt? Yes or no?
Yes, sir.
Give it, give it. Even if you have done only 11th standard, out of 30, 15 questions will come from 11th standard. Out of those 15, you can do all 15. 15 for the 60, 16 to 3, 180, you clear. You clear your JEE main. And if you can clear JEE main with only 11th standard, imagine what will happen when your 12th standard is also done. So, I will end this class here. Give your best. I'll see you in the next class. Take care. God bless all of you. Bye bye.